So many people are present. Only 20 people are present. Okay. Okay. Good morning to all of you. Am I audible?
Yes, sir.
Okay. Shall we start? What all we have studied in the last class? What we have started? That is rectilinear motion. Correct? Or that is called as in linear. Correct? Linear. That is rectilinear. Rectilinear motion. Okay. So here, what all we have studied? We have studied the definition of for the displacement, velocity, acceleration, and also motion of curves, and also equation of motion. Is it correct, all of you?
Yes, sir.
Okay. Tell me, what are the equations of motion? Equation of motion. First one is equal to V is equal to U plus U plus AT. U plus AT. Correct? Next, second one is equal to S is equal to UT plus half AT square. Then third one is equal to V square minus U square is equal to 2 times AS. What is the V? Final velocity. U is equal to A is T is time. Velocity is unit is acceleration unit is okay. Time unit is okay. S is unit for displacement is meter. Okay, you have studied all these things and problems on this also you have seen. Okay, now we will move on the curvilinear motion. Curvilinear motion. Curvilinear motion. Okay, so you have studied that this is V is equal to linear velocity. Correct? Yes, sir. Linear velocity. So if V is equal to linear velocity, so in the when you come into the angular motion or curvilinear motion, I will take omega is equal to angular motion, angular velocity. Then U is equal to what? Initial. This is final velocity, linear final velocity. Okay, final velocity. U is equal to linear initial velocity. Correct?
Yes,
Initial velocity. I will take initial angular velocity is equal to omega naught. Initial angular velocity. Then I will take this S is what? Linear displacement. Correct? So if I take theta is equal to, that is angular displacement. Is it okay? Okay. Then A is what? Linear acceleration. Correct? So in terms of curvilinear or angular motion, I will take alpha is equal to angular acceleration. Time is both sides same. Okay. Okay. Now, can you tell me, whenever a body is here, okay, it has displaced at this point. Okay. Then the displacement, yes. Okay. The time covered T. So V is equal to what? Rate of change of displacement ds by dt. All of you, is it correct?
Yes, sir.
Okay. Then if you want to find out the acceleration, A is equal to what? The rate of change of velocity. Is it correct, all of you?
yes, sir.
Okay. So now, see, here you have written the equation of motion in terms of rectilinear motion. Okay. If I coming to the equation of motion in the curvilinear motion or angular motion, then first equation will be, so here it is v, final velocity. What is my angular velocity? Omega is equal to initial omega, the angular velocity is equal to omega naught plus alpha, a is equal to alpha into t. Then second equation, here it is as the displacement, now it is theta. Theta is equal to ut, u is initial, so omega naught into t plus half alpha into t square. Is it correct? Yes, all of you. Is it
Yes,
correct?
sir.
Yes.
Yes,
Okay.
sir.
Then third equation. Here v square minus u square is equal to 2as. In place of v, what is velocity? Angular velocity? Omega square minus omega naught square is equal to 2 times alpha into theta. Is it correct, all of you?
Yes, sir.
Yes. All of you read on first. All of you read on. First, write on curvilinear motion. Okay, don't write this one. I will tell. First, write on curvilinear motion. Curvilinear motion. Curvilinear motion. The motion of an object the motion of an object moving in a curved path is called as linear curvilinear motion. Curvilinear motion. So next point, read on angular motion. Angular motion. These definitions are important for MCQ questions. Angular motion. The motion of a body about a fixed point or fixed axis as of a planet. Okay. So what is the difference between the curvilinear motion and angular motion? In the curvilinear motion, the motion of an object moving in a curved path. Okay. So in the study you have taken this. Okay, object. These are the particle. Okay, this A and B is marked first. Okay, marked. The object is it has displaced. Okay, I have taken this part. Okay, A and B. Okay, but how it has the body has passed? It has passed like this. This is the path traveled by the object, correct? But AB is parallel to each other only. But path is curved path. That's why this motion is called as curvilinear motion. Okay. Then in the angular motion of an object about a fixed point. Suppose this is a fixed point. Planet is rotating, correct? Means about this point it is rotating. Suppose if I consider a pendulum, okay, the knob of a pendulum is like this. Always it is rotating, correct? So it is rotating about this axis. Okay, this motion is called as angular motion. Angular motion will come under the curvilinear motion. Is it clear, everyone?
Yes, sir.
Okay. Have you taken these two definitions?
Yes, sir.
So next point, important definitions. Important terms. First one is angular velocity. Angular velocity. Angular velocity. These are important. Okay. Can you tell me what is linear velocity? Linear velocity. Yes. The rate of change of displacement with respect to time. Then can you tell me what is angular velocity? Yes. Okay. The rate of change of angular displacement with respect to time. Okay, read down all of it. It is a rate of change of. It is a rate of change of angular displacement. Angular displacement of a body. Of a body. Of a body. And is expressed in okay. How linear velocity is expressed? Or unit for linear velocity. Just I want unit for velocity, linear velocity.
Meter per second.
Meter per second. Then so angular velocity is denoted by omega. Okay. So omega is equal to what is the unit for omega? That is displacement is denoted in radian per second. Yes, it is expressed in radian per second or revolution per minute or revolution per minute. So in short, it is called as RPM. RPM. Have you written? Yes. Yes. Second definition: angular acceleration. Angular acceleration. Angular acceleration. Yes. What is linear acceleration? Yes, rate of change of velocity with respect to time. So can you tell me what is angular acceleration? Yes, it is okay. Read down. It is a rate of change of angular velocity. Angular velocity. Angular velocity. And it is expressed in expressed in can you tell me radian per second square? Radian per second square. And usually denoted by alpha. So angular velocity is denoted by omega. Angular acceleration is denoted by alpha. It may be constant or it may be varying. Yes, next one. Angular displacement. Angular displacement. Angular displacement. Read down definition. It is the total angle. It is the total angle through which a body a body has rotated, has rotated, rotated, and is usually denoted by letter theta. Theta. Mathematically, next line. Mathematically, if a body is rotating, if a body is rotating with a uniform angular velocity, with a uniform angular velocity, that is omega, then in t seconds, the angular displacement is yes, an object is rotating with a angular displacement velocity omega in t seconds. Can you tell me what is the angular displacement? You know that velocity is equal to what? Displacement by time. I want the displacement. Displacement is s is equal to v into t. Correct?
Yes,
अभी
sir, yes.
इधर एक ऑब्जेक्ट है. This is rotating with a angular velocity omega है. In time t है. I want to find out displacement. Theta is equal to
Omega t.
omega into t.
Omega t.
Is it correct, all of you?
Yes.
Yes.
Yes, sir.
Write down, all of you. Okay, this difference you should remember. That is linear motion ko or curvilinear motion ko. What will be the difference? That is angular motion ko.
Sir, his unit radian है ना?
हाँ, yes. The unit is radian. इसका unit क्या आएगा? Radian. Theta is in radian. Is it completed? Yes, sir. Yes, all of you. Is it completed?
Yes.
Yes.
Okay. Can I go for next point?
Yes.
Okay. Right on. The relation between angular motion and linear motion. First, linear motion and angular motion. Okay. So first point, that is particular linear motion and then angular motion. So first one, initial velocity. Okay, all of you read on that. Initial velocity. How it is denoted in linear motion? Linear velocity. U. Correct? Linear initial I am asking. It is U.
U.
Then in terms of angular, that is omega naught. Yes, omega naught. Omega 0. Okay. Then second one, that is final velocity. That is V. Correct? Here it is omega. Then third one, constant acceleration. Okay, that is acceleration. Here it is in linear, it is A. In acceleration, angular, it is alpha. total distance traveled. Okay, total distance traveled. That is the displacement. In linear it is yes. Here in angular motion it is theta. Okay. Then formula for final velocity. Okay. Formula for final velocity. I will take directly equation of motion. Okay. Equation of motion. Here in case of linear, can you tell me? V is equal to U plus AT. S is equal to UT plus half AT square.
Half it.
Then V square minus U square is equal to 2AS. Yes, compare this and tell me. So V is denoted by omega is equal to omega naught plus alpha
Plus
into T.
alpha.
Correct, na? Then S is equal to theta. Theta is equal to omega naught into T plus half alpha into T square. Correct? Then final velocity is omega square minus omega naught square is equal to 2 times alpha into theta. Is this equation correct, all of you? Yes, all of you. Is it correct?
Yes.
Okay. Then differential formula for acceleration. Differential formula. Okay. Wait. Differential formula for acceleration. Yes, A is equal to dv by dt. So in case of alpha, here it is d omega divided by dt. Is it correct? Yes. Next, one more is differential formula for velocity. So for velocity, v is equal to ds by dt, ds upon dt. Then omega is equal to d theta upon dt. Is it correct, all of you? Yes. Write down all these equations. These are very, very important. In case of multiple choice questions, he will ask. And in solving the problem, these all formulas are going to help you. Yes, all of you write down. If you have any doubt, you can ask me. Has completed all of you?
Yes, sir.
Yes, sir.
Can I go for next point? Okay. Next one point. Okay, you have studied linear terms and that is angular terms, correct? Huh? And you have studied equations for the linear motion and equation for the angular motion. Then what is the relation between the linear parameter with respect to angular parameter? दोनों के बीच में क्या relation है वो देखेंगे. मतलब अभी देखो linear displacement पता है आपको, that is s, and angular displacement is equal to what? That is theta. ये दोनों के बीच में क्या relation है? Okay.
Yes, equal to r theta.
Yes, that we will study. Then you know angular velocity, you know linear velocity. ये दोनों के बीच में क्या है relation? Okay, if it is a linear velocity is given, then how to calculate angular velocity? Or angular velocity is given, how to calculate linear velocity? That we will study. So here, whatever you have taken these equations, these are equations of motion in purely linear terms and purely in angular motion. Correct? But I have not given any relation between these two. Is there any relation between these two? I have not given. इधर कुछ भी नहीं दिया. V and omega के बीच में कुछ relation है क्या? नहीं ना. S and theta के बीच में है क्या? नहीं. So then acceleration and alpha के बीच में कुछ relation है क्या? नहीं. So now we will see what is the relation between the linear motion and angular motion. Okay. Right. Relation between angular motion and linear motion. Relation between angular motion and linear motion. Angular motion and linear motion. Can you tell me what is S? S is the linear displacement. Can you tell me what is theta? Angular displacement. Correct? We will see what is the relation between these two. Okay, all of you draw this diagram. All of you draw. And write down this point. And write down. When a particle in a body moves from A to B, the displacement theta is as shown in figure. Displacement, is it a scalar or vector? Vector quantity. Speed is that is displacement distance is scalar quantity. Displacement. This displacement is vector quantity. This displacement is the displacement theta. This is theta. Theta is as shown in figure. The displacement is a vector quantity since it has magnitude. Since it has magnitude and direction. The direction is a rotation. Either the direction is a rotation. Either clockwise or counterclockwise. What is angular velocity? The rate of change of angular displacement. Correct, na? Right. The angular velocity is given by the rate of change of angular displacement. That is omega is equal to d theta divided by dt. Next, the angular acceleration is given by what is angular acceleration? The rate of change of angular velocity. That is alpha is equal to d omega divided by dt. So this omega I can substitute d theta by dt. Okay, then what it will become? D square theta divided by dt square. Is it correct, all of you?
Yes, sir.
Yes. The angular acceleration may be expressed as in another form also. That is alpha is equal to, what is alpha? D omega divided by dt. Okay, so this can be written as d omega divided by d theta into d theta divided by d omega. Is it correct? Dt by chain rule. Okay, d omega by dt is equal to d omega by d theta into d theta by dt. Is it correct, all of you? Yes or no?
Yes, sir.
Okay.
Yes, sir.
Then alpha as it is. D omega by d theta means what? D omega divided by, wait a minute. D theta by dt means what? Rate of change of displacement with respect to time. मतलब क्या है? Omega. So I will write it is omega. Then I will write this one as it is. D omega divided by dt. D theta. D omega divided by d theta. This will be asked in your multiple choice questions sometimes. Okay. This will be the formula for angular acceleration. Angular acceleration alpha is equal to omega into d omega by d theta. Is it understood all? Omega is equal to d theta by dt. Alpha is equal to d square theta by dt square or d omega by dt. And alpha is equal to omega into d omega by d theta or d omega by dt. Okay, alpha value. Yes, is it understood? Can I go for next point? Still not completed.
Complete, sir.
Completed? All of you.
Yes, sir.
Okay.
Yes, sir.
So, write down first. When a particle moves from, नहीं वही point उसमें next continue. When a particle moves from A to B, the distance traveled by it is yes. If r is the distance, if r is the distance of the particle, from the center of the rotation, then okay, all of you concentrate here. This is a point. Okay, this is a line and this is a curve. Okay, curve, and length of this curve is L. Okay, and this is a radial distance R, and angle covered by this arc is theta. So in the mathematics you have studied, what is the length of the curve? Length of the arc of a circle. L is equal to, what is its length is equal to in terms of r and theta? L is equal to r theta. Have you studied in your mathematics? Length of arc of a circle is equal to r into theta. Have you studied all of you this one in your mathematics?
Yes, sir.
All of you, have you studied or no?
Yes, sir.
Okay. See, this is a object. Initially, it is in the place A. It has covered a distance B. That is A to B aane ke liye, what is the distance it has covered? Yes. Okay, that is linear. Okay, it is. Then about a point O, the distance is R. Okay, and how much it has covered in terms of angular? It is theta. So S is equal to R into theta. Can I write?
Yes.
Correct or no?
Yes,
Correct.
sir.
No? So therefore S is equal to R into theta. S is equal to R into theta. This is the relation between the that is angular displacement and linear displacement. This is linear displacement S. This theta is angular displacement. So S is equal to R into theta. So whenever the linear displacement is given, if you want to ask you for the angular displacement, you should know S divided by R is equal to theta. Okay. So next point. So that is the tangential velocity. The tangential velocity of a particle is called as linear velocity. And is denoted by how linear velocity is denoted? Linear velocity v, and is denoted by v. Okay. Thus so v is equal to, in terms of linear displacement, what is v is equal to? Yes,
Ds upon dt.
ds is equal to ds upon dt. Now you know S is equal to in terms of angular displacement. Can you tell me what is angular displacement? D by dt of S is equal to what? R into theta. Okay.
Yes, sir.
So here what is R is constant. Correct? Can I take outside? R into d theta divided by dt. Is it correct, all of you?
Yes, sir.
What is d theta by dt?
Omega.
Rate of change of angular that is angular displacement with respect to t, that is angular velocity omega. So v is equal to R into omega. What is the relation between? Now it is angular linear velocity is equal to R times of angular velocity. Here linear displacement is equal to R times angular displacement. Okay, yes, right on. समझ में आ रहे हैं ना सभी को?
Yes, sir.
क्या linear acceleration r times of alpha. Okay, we'll see r होते क्या, r square होते क्या? Yes, you can tell me what is the linear acceleration is equal to? Linear acceleration is equal to dv by dt.
dv by dt.
Okay, v is equal to, you know, ds by dt or r into d theta by dt. Then what will become linear acceleration? R into r square. Huh? Okay, we'll check. Have you completed?
Yes, sir.
Can I go for next slide?
Yes, sir.
Okay. Then right on. The linear acceleration. Acceleration of a particle in tangential direction, tangential direction is AT. Okay, tangential direction is given by S. Tell me what is linear acceleration? AT is equal to, that is dv by dt, correct na? dv by dt. Okay, now you know that what is v. So I will write d by dt as it is, d by dt. So from the previous formula, what is v? V is equal to r into here. What is r into d theta by dt? Correct. So can I write this one? R into d theta by dt. R is constant, so I will take outside. So it is r into d square theta divided by dt square. Yes, this is the formula. Et is equal to r into d theta square, d square theta, d square theta divided by dt square. Is it alpha square? Yes, sir. D theta by dt, d square theta by dt. Alpha square is okay. Okay, we'll write down alpha square is okay. Alpha आएगा. Yes, this one you have to write. So this d square theta divided by dt square. Yes, wait a minute. Just check here. Yes, alpha is equal to d omega by dt. Okay, omega is equal to what? Omega is equal to here check it. Omega is equal to, from this equation, d theta by dt. So here can I write it is d by dt of omega is equal to d theta by dt. All of you. So can I write it is d square theta divided by dt square? All of you. Is it correct?
Yes, sir.
Yes. So alpha is equal, in place of d square theta by dt square, can I write alpha? Yes. So that is equal to r times of alpha. R times of alpha. R times of alpha. Yes. All of you read on this now. Again, there is one more term. What is this d theta by dt? D theta by dt is what? Omega. So can I write this one in terms of omega? R into omega square. Can I write?
Yes, sir.
Is it correct? No. Yes.
Yes,
So
sir.
this is equal to r times of omega square. R times of omega square. Okay, all these formula you have to remember. Acceleration, linear acceleration is equal to r times of angular acceleration, or r times of linear velocity square. Okay, r into omega square. Angular omega. Okay. Square कैसे आ गए? अभी देखो d theta by dt, because I will write because what is d theta by dt?
Omega.
Omega. So here क्या है? d square theta है. R as it is I have written. So d theta by dt
Yes,
is
sir.
omega square हो गया. नहीं अभी d square theta by dt. एक मिनट. So ये दोनों साइड स्क्वायर कर सकते हैं. dt by dt square whole square is equal to omega square. Correct? So instead of writing like this, you are writing d square theta by dt square. Correct? That is double क्या बोलते हैं? Double differentiation. dy by dx ऐसे नहीं बोलते. Whole square is nothing but d square y by dx square है ना? So it is same as. That's good as same. Okay. Is it completed, everyone?
Yes, sir.
So now you know the difference between the linear and angular parameters. So you know first of all you have studied how it is denoted. Okay. First you have studied what is the important terms. Okay. Then you have studied how it is denoted. Then you have studied the relation between the angular and linear velocity. So angular velocity is equal to, yes, what is angular velocity is equal to? First of all, angular displacement is equal to r times of, linear
Theta.
displacement is equal to r times of angular displacement. Correct? Yes. Then linear velocity is equal to r times of angular velocity. Then linear acceleration is equal to r times of angular acceleration, or r times of linear angular velocity square. Okay. So like this, you should know all these definitions. Is it understood, everyone?
Yes, sir.
Can I go for problem?
Yes, sir.
Write down one important problem. Okay, this will be important for the examination. In the today's test, chapter number 3 and 4. Okay, I will ask the questions from the CGMI and trust. Okay, 6 MCQ questions, 3 from trust, 3 from CGMI, and 2 Moscow 2 questions. There will be 3 questions. You have to answer 2 questions. So 6 plus 6, 12 हो गया. So there will be 4 problems of each carries 6 marks. You have to answer any 3. 6 into 3 is 18 plus 12, 30. Okay. 2 problems from the trust, 2 problems from the CGMI. Okay. That is a simple problem you have to solve. Okay. Right on the question. Yes, this is important for the exam. The rotation of a flywheel. The rotation of a flywheel is governed by the equation omega is equal to 3t square minus 2t plus 2 plus 2, where omega is in radian per second and t is in second. After 1 second, from that start of the angular displacement was 4 radians. Determine the angular displacement angular velocity and angular acceleration of the flywheel when t is equal to 3 seconds. T is equal to 3 seconds. So don't write on anything, just concentrate. What is given? So given. Yes, first is the rotation of flywheel is given by the equation omega. What is omega means? Angular velocity, correct? 3t square minus 2t plus 2. Okay. Omega is in radian per second, t is in second. After 1 second, that start of the angular displacement was 4 radian. So what does it mean? So can I write it easy? Omega is equal to d theta by dt. So he has given d theta, that is 4 radian, correct? 4 radian divided by 1 second, correct? All of you, that is nothing 4 radian per second. That is angular velocity is given. Then determine angular displacement, angular velocity, angular acceleration when time is 3 seconds. Okay, so this is angular velocity is known. I want to determine displacement. So angular displacement is equal to displacement. What is the formula? Angular displacement.
Theta is equal to
Theta is equal to
yes
theta is equal
upon
to S upon R. Okay, wait, S upon R. Do you know S? Do you know R? कहाँ है R? कहाँ है? You don't know. So you know the value whenever ds by dt is given. Okay. So what is this ds by dt? That is v. So whenever only s function is given, Okay, that is some function. So can you determine velocity? That is integration of dt, integration dt. So here he has given velocity. I want displacement. So don't get confusion. Velocity function is given. Velocity function. Okay, I want displacement. So how to find out velocity displacement? Integration of velocity function. Correct, na? All of you. Correct? Yes, online. Students, is it correct or no?
Yes, sir.
Yes. So what he has given, omega is given. I want to find out the theta, displacement. Okay. Velocity is given. I want displacement. That is nothing but integration of integration of omega. Integration of omega. That is equal to integration of 3t square my divide sorry 3t square minus 2t plus 2 into dt. Okay. So integration, that is 3t cube upon 3 minus 2t square upon 2 plus 2t plus c. Correct? Everyone?
Yes, sir.
Okay. You know that he has given when time is equal to 1 second, 1 second. What is theta is equal to 4 second? No, sorry, 4 radian. He has given 4 radian. Correct? So substitute in this. So this implies theta. Okay, theta is given. Theta is equal to 4 is given. Is equal to this 3 get cancelled. T cube. T cube means 1 cube. 1 cube time 1 plus sorry minus it is minus 2 to get cancelled 1 square, that is 1 square plus 2 into 1 plus c. So these two get cancelled. So 4 minus 2 is equal to c is equal to 2. All of you, c is equal to, is it 2? Have you understood? Okay. Now I will write this function, theta function. Okay, what is that one? Theta is equal to t cube minus t square plus 3t c plus c था plus c जगह पे क्या आ गया? 2 आ गया. Correct? This one. Okay, whatever this one. C is equal to 2. Plus 2t, correct? Plus 2t. Plus 2t. Okay, 3t nahi na. That is 2t plus 3. So this is what theta aa gaya. Okay. This is 2 aa gaya. Next, I want to omega. Omega is equal to what? Omega is equal to what? Formula he is given. 3t is whatever the given function. 3t square plus minus 2t plus 2. Correct? So I want to determine alpha value. How to determine alpha value? Alpha is equal to d omega divided by dt. Correct? So that is equal 3 into tell me 2t minus 2. Okay, correct? That is equal to 6t minus 2. Correct? So what is asked? He is asking you have to determine angular velocity, angular displacement, angular acceleration of a flywheel when t is equal to 3 seconds. Means whatever I have determined all these 3 patterns at t is equal to 3 seconds. 3 seconds में कितना रहता? Okay, so at time t is equal to 3 seconds. Okay, then theta is equal to, substitute 3 cube minus 3 square plus 2 into 3 plus 2. Calculate how much it is. 26 or 27? 26. What is the unit for the theta? Radian. Okay. Then omega is equal to 3 into 3 square minus 2 into 3 plus 2 is equal to, that is equal to 23. What is unit?
Meter per
Radian per second. Radian per second. Then alpha value. Alpha is equal to substitute 60 minus 2. 6 into 3 minus 2. that is equal to 16 radian per second square. Radian per second square. So these are the answers required. Is it understood, everyone? Yes or no?
सर ऊपर की स्टेप रिपीट करिए.
Okay, I will repeat. Just see. So he has given, what is this function? What is this function? Velocity function is given, correct? Yes. And he has given theta when time t is equal to 1 second, and when time t is equal to 1 second and theta is equal to 4 radian. So we know that angular velocity is equal to d theta by dt. Okay, so 4 is given, 1 is given, so 4 radian per second. Okay, next he has given angular velocity function. So theta I want, angular displacement is equal to integration of angular velocity. Okay, dt, yes, here I need to write dt function. Then so when you integrate, you will get theta function. Okay, so he has given t, he has given theta, substitute, you will get the constant c value. C is equal to 2. Up to this much, is it understood, everyone?
सी टू सर टू
C
का
क्यों? The integration constant. ये इधर देखो, 3t स्क्वायर को 3t क्यूब by 3 आ गया, माइनस 2t को 2t क्यूब स्क्वायर by 2 आ गया. इंटीग्रेशन 2 is 2t प्लस c आता है ना इंटीग्रेशन में. Yes or no? Integration constant c आता है ना?
Yes, sir.
हाँ. Yes. So you know parameters t का value दिया, theta का value दिया. So substitute, you will get the value of c is equal to 2. कौन सा इक्वेशन में सब्स्टिट्यूट करने का? These two equations for a equation में सब्स्टिट्यूट करना थीटा में. So you will get theta, c value. Then write down all the theta, omega and alpha in terms of function. So theta is got, omega is known, and alpha you have to determine. Alpha is equal to d omega by dt. Okay. So at 3 seconds is asking. So substitute in this equation, t is equal to 3 seconds. So that you will get theta is equal to 26 seconds, omega is equal to 23 seconds, and alpha is equal to 16 radian. Okay, radian per second square. Is it understood? Yes, sir. Yes, write down also. Just all of it, just take the screenshot. दोनों slides जिसका भी. Okay, so I will stop now. To continue next class. Have you taken screenshot?
Yes, sir.
टाइम नहीं, स्वर आ गए. Okay, ये दोनों का screenshot ले. We'll stop now. I want to take the attendance. Just 1 minute में attendance ले. Okay, I will stop sharing. 26, 7, 8, roll number 10. 10. 11, 12, 13, 14, 15. 15, 16, absent, 16, okay, 16 absent, 17, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 34, 34, 36, 37, 38, 38, 38, 40, 41, 42, 43, 44, 46, 47, 48, 52, 56, 57, 58, 59, 60, 61, 61, 62, 62, 63, 64. Okay, absent numbers 16, 17, 38, 62, 63, 64. Okay, so we'll stop now. We'll continue in the next class. Thank you all.